Okay, hi guys. Here's just a quick little review video on um, the guided notes, right? For 8.2 and 8.3. So let me really quickly go over the new vocab words in 8.2 and 8.3 for similar triangles. If we want two triangles to be similar, right, it has to follow this definition where their corresponding angles are congruent, they're exactly the same, but their sides are proportionately different based on a scale factor. So that means their angles could be exactly the same, but then their sides are different sizes, right? They're different sizes. So when we look at these triangles given to us, we know that these two triangles, actually we're trying to figure out whether they're similar or not, and we could do that using these theorems, AA, SSS, or SAS. Okay, we're using one of those three theorems, right? In AA, the corresponding angles have to be congruent. They have to be equal to each other, right? And in SSS, the sides don't have to be equal to each other. They just have to have the same scale factor. Okay, they just have to have the same scale factor. And then same thing SAS, two pairs of sides have to have the same scale factor, and then one angle has to be equal. So let's look at this in number one. Right, I kind of went over this, I went over this in class, but let's go over number one. All right, we have three theorems. We have AA, SSS, or SAS, and we're trying to figure out, okay, which theorem would work the best here. Based on what we're given three different sides of the triangle, right? We're given three different sides of the triangle. We're not given any angles. We're not given any pair of angles that are congruent. So just based on that, we're probably going to use SSS. Okay. Now, we need to, using this definition here, we need to set up a ratio of corresponding sides. So that part might be tricky. How do I know which side? Oops. How do I know which side is congruent to which side? So on the smaller triangle, right, we have these sides, 9, 10, and 12. So I'm asking myself the question, between 9, 10, and 12, which one's the smallest? Oh yeah, that's 9. Alright. And on the other triangle, the bigger triangle, 27, 30, and 36, between those three numbers, which was the smallest side? Right? And I'm like, okay, wait, 27 is the smallest side. So I'm going to make sure I match them up, right? They're corresponding. So for my first ratio, I'm going to put 9 over 27. And I set up my ratio and I'm thinking to myself, okay, then what is the greatest common factor? I know I can simplify this. What's the greatest common factor? It's 9, right? 9 is the greatest common factor here. So 9 divided by 9, that's 1. 27 divided by 9, that's 3. Okay, next one. Okay. So that's already one pair. And now the goal is the other ratios, all of them need to have this 1 over 3 scale factor. Then we can say the triangle is similar, right? So, I'm trying, okay, after 9, what's the next smallest number? 10. Same thing after 27, what's the next smallest number? That's 30. So I know that 10 and 30 are going to be corresponding. I set up my ratio, and what's the greatest common factor here? Again, it's 10, right? 10 divided by 10 is 1, 30 divided by 10, 3. Okay, I got 1 over 3 again. We're on the right track here. What about that last pair of sides? Okay. 12 is the biggest side, 36 is the biggest side. So I'm putting them on the ratio. What's the greatest common factor here? 12. Yeah, 12, right? 12 divided by 12 is 1. 36 divided by 12 is 3 again. Okay, so they all have the same scale factor, 1 over 3. What does that mean? That means the two triangles are similar, right? Every side on the smaller triangle, every side is a third of the size of the bigger triangle. Okay? So then, okay, by SSS theorem, we know that these two triangles are similar. If it's starting with H and then G and then F, H, G, and then F, oops, the wrong way, right? H, G, and then F. Then on the other triangle, go in the same order. B, C, E, C. Alright, if you're kind of confused on that, just make sure you mark them right. H, G, F. H, G goes through 27, which is the smallest side, then the middle side, then the biggest side, then the middle side. Same thing here. Smallest side, middle side, biggest side. Okay. Alright. So that's number 1. 1 second. Okay. Let's try number 4. All right, let's try number 4. So here, again, I'm asking myself the same questions. Is this going to be AA, SSS, or SAS? What the heck? Let me get my other pen. I'll be back. Okay, right? So we're asking ourselves the same questions here. Let me rewrite this. AA. Oh my god, this pen's not working either. A. AA. What? SSS or SAS. Okay, my goodness, it took way too long. And now you're looking at the information I was given to you. I see a side, angle, and inside, side, angle, and a side. Okay, so we're probably going to use SAS here. So let's kind of move forward with that. We're using the SAS theorem. So match the sides again, the same way we did in number 1. In this smaller triangle, right, between 21 and 17, 17 is the smaller side. So in the bigger triangle, between 24 and 33, again, 24 is the smaller side. So when I set up my first ratio of sides, I'm going to put 17 over 24, right? You could have also done 24 over 17. It doesn't matter. Do they have a common factor that we can divide by? If you're thinking no, that's true, right? 1 is only divisible by 1. 17 is only divisible by 1 or 17. And 24 is not divisible by 17 at all. So right here, this is it. This is the most you can simplify. That's your scale factor, okay? So we're just trying to make sure if the other side also has the same scale factor. As for the angles, right, do we have a pair of congruent angles here? We do, right? It's just H, angle H is congruent to angle P. They both have one arc mark. And then what about that last side? Okay, let me do the last side in a different color. That last side is going to be 21 and 33. So 21 over 33. Let me ask you this. If I did this, is that okay? Right? technically your answer is going to be no. It is not okay. Because if you started that first side, right, with small over big, you took a side from the smaller triangle and then put it over the side from the bigger triangle, then you need to do the same thing here. This side also has to be small over big. And right now it's at big over small. Okay? So you make sure you do 21 over 33. They have a common factor here. That's going to be 3. Right? So that's 7 over 11. 7 over 11 and 17 over 24. Are they the same scale factor? No, not the same scale factor. Right? So that means triangles are not similar. Okay? Are not similar. Right? So if you want to write that in terms of math, PQR is similar to HGF, right? And you're just going to put a little cross, a little slash through the similar sign. That means not similar. Okay. Okay. Let's do one more. Let's do. Let's do number 3. Let's do number 3. I'm going to do the same thing here on number 3, right? I'm asking myself, is it AA, SSS, SAS? Actually, let's do number 3. That's fine. That's whatever. And again, I'm looking at the information that's given to us, and this is clearly going to be SAS, right? We have 2 pairs of sides and 1 pair of angles. So again, let's set it up. The first pair of side is going to be smaller triangle, bigger triangle, 250, and then between 78 and 60, 60 smaller, so 50 over 60, divide by 10. So that's going to be 5 over 6. Okay. Congruent angles is going to be B and P. Angle B is congruent to angle P. Again, how do I know? They both have two of the marks. And then the last one, congruent side. Alright, and then there's only 1 pair of sides, 1 less pair. 65 over 78. This is the part where finding the GCF, it takes a lot of practice. Maybe you've tried everything. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's actually 13. It's kind of crazy. So 65 divided by 13 is 5. 78 divided by 13 is 6. What do you know? The scale factors match this time, right? They have the same number. So these are similar, right? The triangles are similar. PQR, BCD. PQR is congruent to triangle BCD. I mean, sorry, not congruent. Similar. Okay. All right. That's 3 problems. Try the rest on your own. So you're going to get stamped and checked another day. All right. Bye-bye.